Oh, mechanics is so difficult. How should I study for mechanics? Shear force and bending moment was never my cup of tea in school or in college. These are the kinds of queries that students come up with when they reach out to me for guidance. So today what I'm going to do is I'm going to solve a few variety of questions from mechanics, because if you look at it otherwise it's a very easy subject. So let's get started. So the first question is of a cantilevered beam of length 5, in which at the free end you have a point load of 20 kilonewton and a uniformly distributed load of 10 kilonewton per meter across the entire length of the beam. So under such circumstances, what you should ideally do is you should separate the loads visually, in your memory, and then add up the summation of forces and the moments and then get the final answer. So what I will do here is, and by the way, I am not looking at any solution, I am looking straight into the camera. So if I can do this sum mentally, you can always look at the paper and do it yourself. So that's how easy mechanics is. So the moment imposed at the fixed end because of the loads on the free end and the across the entire length of the beam would be, at the free end you have 20 into 5, which is 100, right? So 100 kilonewton meter of moment is being imposed, plus the uniformly distributed load is 10 kilonewton per meter of the beam. The beam is 5 meters, so total load is 10 into 5, 50 kilonewton. Now a uniformly distributed load would be acting from the center of mass of the entire load system. So this load of 50 kilonewton is effectively acting from a distance of 2.5 meters or half of 5 meters, 5 by 2 from the fixed end. So 50 into 2.5 gives you 125. 50 into 2 is 100 and a half of 50 is 25, so 125. And you had 100 kilonewton meter of moment because of the point load at the free end. So 100 plus 125 gives you 225 kilonewton meter of moment at the fixed end because of the combination of the point load and the uniformly distributed load, and that's how easy this sum is. So the next question is of a building with a live load of 12 tons and a dead load of 18 tons, or maybe a dead load, live load of 12 tons and a dead load of 18 tons. So a total load of 30 tons in all. So let me give you an example of what they mean to ask in this question. As you have noticed, they have also given a factor of safety. So why do we need a factor of safety? So I'll give you an example as I've mentioned. Let's say your building, the building in which you are living in, weighs 30 tons with your weight added onto it. But on one fine day there might be a gathering, a family gathering or so. So 50 people might be coming over to your house. So if I have designed the building sufficiently well to counter the load imposed by its self weight with you inside of it, that's fine. But the day 50 people get inside your building, if I have not taken extra caution to account for that extra imposition of load, maybe on that fine day the building will collapse, killing all 50 inhabitants then and there. So that is why you should always take a factor of safety. This is just a layman's example. There are technical reasons why you need a factor of safety, but for your understanding at a very basic level, this is why we should take a factor of safety. Now why is factor of safety 1.5, 2 and all? You would have to get into IS codes and all these technical subjects, but I'll keep it for some other discussion. So they have given a factor of safety of 1.5. A factor of safety of 1.5 means a load of 12 plus 18 is 30, but you have to consider 1.5 times that load. So 1.5 times of 30 is 45. So you would have to consider a load of 45 kilonewton and the soil bearing capacity, which means the amount of load this soil can sustain without collapsing or caving in. So this amount of load which the soil can sustain has been given as 10 tons per square meter of the soil. So you would definitely need, now that you have 45 tons of load being imposed, if you're making a foundation, you would have to make it of an area of at least 4.5 square meters, because 10 per square meter, so 4.5 square meters would account for the 45 tons of load being imposed. And again, I did not look at the solution, did not look at my computer, I just know the logic and I spoke to you directly. So if I can do it, why can't you do it in the exam? So let's move on to question number 3. These are very easy questions. No, the questions are quite technical, the solution and the understanding are very easy. So you have to be confident in yourself, look for proper guidance, right mentorship, and then mechanics is very easy subject, at least at the level of architecture. Let's move on to question number 3. Question number 3 is of a truss, but because it's a truss, what I'll have to do is I'll have to minimize myself and maximize the size of the image, because truss is a very technical subject. There are two methods, method of joints and method of sections, that you must learn and understand, but only when you've perfected the art of shear force and bending moment diagrams and you understand the concepts behind reaction forces and all. Because if you do not know why we do not have a reaction force in the x direction on a roller joint, and why we have such a reaction force on a fixed joint, these basic concepts if you don't know and understand, you will not be able to solve the method of joints and sections. Then obviously the law of statics apply, summation of forces in the x direction, the y direction, summation of moments, they have to be taken care of. So in this question we can see that there is an image of a truss which has been given to you, and the truss has two actions or two forces acting, one in the x direction, one in the y direction, at 15 kilonewton and 25 kilonewton of load x respectively. And there are two fixed points, one is two joints, one is a roller joint and one is a hinged type of a joint, and there are 1 2 3 4 5 6 7 1 3 4 5 6 7 members. And how many joints are there? 1 2 3 4 5 joints are there, each of length L. So obviously now we know what the diagonals are going to be, it's L root 2, because it's a square and diagonals are root 2. So let's move on to the solution now. First of all, straight away use the law of statics and find out the forces in the x direction and the y direction. So the forces in the y direction add up to be 0, because the truss by itself does not fly off into space. So it means the resultant of all the summation of forces in the vertical direction is nil, because it is still there, it's statically there, it's not moving by itself. So there is no resultant force. Similarly in the x direction also there is no resultant force, it's not moving in one direction on the x axis or the other direction on the ground on the other side of the x axis, it is static. This is the concept first that you have to understand, it is statically stable. Next, the third point, the truss is not rotating about a point like a helicopter's blade, so there is no resultant movement also. The summation of all the movements and the deforming forces is 0, it does not rotate by itself. So these are the three major concepts that if you accept and agree with, we can move on to the next level. So summation of forces in the y direction I have considered to be 0, which is fine. So both the reaction forces in one direction minus the action force of 25 kilonewton in the opposite direction add up to be 0. So reaction forces are a summation of 25, and summation of forces in the x direction is also 0. So reaction in the x direction at point C is 15, because 15 is in the opposite direction, it's straight away an inference. Now taking moments, let's say we take a moment at C. Now strategically, why did I take a moment at C? Because if I take a moment at C, the distance of these forces, these two reaction forces at C from the point C is 0. So force into distance would be force into 0, so that's 0. So I would immediately eliminate two unknowns, I would just have one unknown, which is the third reaction force. So that way I can easily find out the reaction force of my interest, because I have to find out the force in the member, I think AB they have asked. So if I am looking for that, I would first of all quickly move over to reaction force in A, because that deals directly with AB. So applying the formula of moments, it's equation of moments, and assuming, let's say, anti-clockwise is positive. For the purpose of your rough work, you can take anything positive, negative, doesn't matter, but international standards consider anti-clockwise to be positive. So 2 times, okay, whatever the equation is, you can just solve it, and I have got that reaction, the magnitude of the reaction forces at A is 20. How did I get? Okay, somebody has just told me, please explain. So I'll explain the equation. Reaction force at A taking moment at C, the reaction force at A is trying to rotate the entire truss system around the point C anticlockwise. So now here I have taken the distance at which the reaction force is acting from the point C, which is 2 times L, because L is the length of each member and there are 2 members which connect A to C. So the distance is 2L, and that's how I have considered 2 times length into reaction or the force. So force into distance is 2 times of L. So F into 2 times of the distance gives you an anti-clockwise movement. But the thing is, there are 2 other forces that we have to account for. The force of 25 kilonewton is trying to rotate the entire truss system around point C in the clockwise direction. So clockwise direction is countering the anti-clockwise direction. So if I consider anti-clockwise positive, I would consider clockwise negative, just for the symbol, the signage of the magnitude. So I'll consider this a negative magnitude. So I will have a subtraction, and 25 is the magnitude, and distance of this force from the point C, the distance of the line of action of force, and not the point at which the force hits, no, the line of action. So if the line of action extends to infinity, the line of action is at a distance of 1 times L. So that is why I have considered 25 into L. And also this magnitude of 15, which is in the x direction, is ultimately trying to rotate the entire truss system around point C in the clockwise direction. So clockwise we were considering negative, so we'll take negative for the magnitude of clockwise movement. So again for 15, and the line of action of force for 15 around point C is a distance of L away from that point C, clockwise rotation. So we'll have minus 15 times of the length. So obviously the lengths get cancelled out because other side is 0, and these, okay, now these 3 add up to be a summation of 0 movement. So obviously L's get cancelled off. So reaction at A, you end up with a magnitude of 20. So but the very first equation which you have derived told you that the summation of forces in the y direction is 25. So 20 plus 5, 25. So reaction at C must be, the vertical reaction at C must be 5, and the horizontal reaction at C anyways you know is 15. So now you know all the 3 reactions. So let's move on to part 2 of this answer, where you will actually find the magnitude of force in the member AB. In the second part, we will focus specifically on joint A. At joint A, you have member AB and member AD, D we have assumed at the top, so member AD, and you have the reaction force. Forces would be anyways traveling in the members, and those of you who have done our sessions would know we assume when we assume a force in a member, we assume it to be a tensile force, so it's moving away from the joint. And then if you get the negative answer, which means it's a compressive force, so we'll change the direction later on, but we'll start with the assumption that the force is moving away from the joint. So AD is moving away from joint A at an angle of 45 degrees, because it's a perfect square and this is the diagonal, so 45 degrees. Again a trick for the exam. Some people will tell you, if you have to segregate the force, the inclined force, into resultant components, please take care of sin theta, cos theta. At 45 degrees you don't care, sin theta, cos theta, take anything. Let's say you are a very weak student in maths, take anything. 45 degrees, both sin cos is same. So but for the technical side of it, let's say the cos theta is between the theta we assume between the members AD and AB. So if we take the vertical component of the force AD, the force AD now, which is at an angle this way, if you take the vertical component of it, this component would be the sin theta component. So AD sin theta, and what is the other vertical component at joint A? At joint A you would have AD sin theta, and the other vertical component would be reaction at A. That's all. There are no vertical forces. So reaction at A moving upward plus AD sin theta moving upward, both let's assume positive, upwards is let's say positive. So AD sin theta plus reaction at A, which is 20, these two are not creating any resultant movement in joint A. Joint A is not flying off into the air. So AD sin theta plus 20 equals 0. So now you know that AD sin theta is negative 20, which means if you had considered this upward, this should actually have been downward. That's fine. But sin theta is, sin 45 is 1 by root 2. So AD by root 2 is minus 20. So AD itself, this AD working at an angle itself is minus 20 root 2. We are very close to the final answer they were looking for in the exam, which is the force in member AB. Now, the force in member AB is a horizontal component. You know the vertical force. You know the force in member AD, which is acting at an angle. So the sin theta component is vertical, but the horizontal component for AD cos theta is horizontal. This is countering the force in the member AB. So AD is 20 root 2, cos theta is 1 by root 2. So AD cos theta is 20, and this is countering AB. AD is 20 root 2. AD cos theta is 20 root 2 into 1 by root 2, that's only 20. So the force in member AB is 20 because AD cos theta is countering AB. There are no other horizontal forces along or on the point or the joint A. So that is how you get the answer for this question, as the magnitude of force in the member AB is 20, and that's all. This is supposed to be a 2-minute worth of a sum. It shouldn't take you more than 2 minutes in the exam. If it does, move over to the next sum because you won't be able to solve it otherwise. It's a very easy concept, but you have to be very strong in the foundation of mechanics. Then these things are very easy. You can even do it mentally. I started off by trying to look at the laptop and dictate the answer, but I ended up not looking at the answer and doing it completely mentally because my foundations are strong and these things are very easy. So I could do it, I think you are in a much better position to do it. So let's move on to the next question. Okay, this question I would rather rate it as a difficult question for the students of architecture in the GATE exam, because anyway students are nervous. Suddenly you give them something like this, if they haven't seen it before and they do not have a strong concept, this question type is what segregates the top 100 from the bottom 100, bottom whatever number, or the top 100 from the rest. Okay, so they've given a diagram, or I think something like a bending moment diagram in a triangular, the triangle. Okay, so they've given this bending moment diagram with the peak at 36 kilonewton meter. So the moment you look at the bending moment diagram being a triangle, you know the load is a point load, and the magnitude of bending moment is 30 kilonewton meter. You try solving it by the generic method, it will take you 5-7 minutes. You try and solve it by my method, which I share with in private with those who reach out to me for guidance. It will take you 5 seconds. The moment you look at the lengths, 3 and 4, you look at the ratio of the lengths, you know, okay, this weight is going to be 4 by 7, that's going to be 3 by 7. So let's say this is 4 by 7 of an x, the unknown amount of load, and the distance is 3. So 4 by 7x into 3 equals 36, that's all. So 12 3s are 36, so 7 3s are 21, unknown load is 21 kilonewton. Hardly it should take you 5 seconds to solve by yourself if you use my method. For the time being it's proprietary, so I won't be able to share my method online, but yes, if you reach out to me in private, definitely we can have a talk over it and you would know. So let's move on to the next question. Now I have listed out the solution for this sum, but the solution is pretty straightforward. You get the formula in IS 456. If you have read the code, and you need to read the code if you want to get into the top 100, and if you know what the question is asking, they are actually asking of a composite bar like that of a reinforced concrete column, because RCC columns have both concrete and reinforcements which is steel or treated steel, especially tempered steel. So it's a composite bar combining two different materials of different degree of expansion under the same conditions of temperature difference, and how would they behave, how much expansion or how much load they can take under certain conditions. So if you follow IS code, that's a different story, but for this question specifically, again it's a rare question, one-off question, but yes, conceptually very simple. Look at the formula. The formula is the only thing that you have to remember. I generally point out where the location of this formula is in IS code. I'll also try and link it in the description below, the page number of IS code and a copy for the IS 456. And you would know, because it's a composite bar, they have specifically mentioned 1% steel. As per the IS code as on date, the maximum steel you can have in a composite bar is 4%, because otherwise, let's say you say the amount of steel in the composite bar is going to be 99%, so just 1% concrete, so it turns out to be a steel beam, so that's not possible. So the Indian Standard Code mandates that the maximum it can be is of 4%. So here they have given 1%, so it means 99% concrete and 1% steel. How do they behave in tandem, in conjunction, and how much load it can take in total? So for that you just have to use the formula. So they have mentioned 1% steel specifically because they are looking at a composite bar and how this bar is going to behave, or the composite RCC column or RCC members going to behave under load conditions. So they have, you have 1% steel, which means you have 99% concrete, and the formula you should remember 0.4 FCK or characteristic strength of concrete, and 0.67, if you forget 0.67 is basically 2/3 of a ratio, 0.67 characteristic strength of steel. So these FE 450, 550, 500 bars that you get in the market, these are characteristic strength of that steel bar. So that's why they advertise the higher the strength of steel, the more expensive it is, but the more higher or maybe more robust structures you can make with it in the market. So the next question again asks you, what is the meaning of a M25 concrete? It's basically the a measure for the amount of load that the concrete can take sufficiently without collapse, which is 25 Newton per square millimeters. The options are pretty easy. If you just go through the theory once, you would know, but otherwise if I was in your place trying to make the question very hard, I would play around with the I would keep everything at 25 and play around with the units, Newton to dyne, centimeter square to meter squared, completely confused. You had to be absolutely sure of the answer, and I would definitely not give 25 Newton per millimeter squared. I would have made these many newtons per centimeter squared. So you have to calculate it back. Even the right answer would have to be calculated. So that's how they can play around with the concepts, but basically it's the fundamentals. If your fundamentals are clear, you need not worry about the answers or the whatever questions they throw at you. So let's move on to the next question. Now this question asks us, what is the nature of load transfer in a flat slab? So straight away, for a flat slab they've made it very easy for you, but they've given you difficult terminologies which generally people don't discuss in any session that they do for the GATE exam. So they've given membrane action, plate action, vectors action, or beam action. Straight away you know beam action is beam column, so but the nature of transfer of load through columns and then through beams, straight away you know, okay fine, this is beam action. For flat slab, not the case. Anyways, why do we have a flat slab? Let's say you have a piece of paper and then you want to put it into the punching machine to make 2 holes. So flat slabs, if you have a very thin slab and if you have a longer spans, a lot of load is imposed on the slab. So you have a flat slab type of an arrangement to allow for longer spans and to counter punching shear. Otherwise the column would tend to punch through the slab itself. So that you have to counter punching shear, and also you have to provide for longer spans, so you go for a flat slab with or without column heads, so that's a separate discussion. Anyways, let's say membrane action. You must have seen many of the tensile surfaces or tensile structures designed by Zaha Hadid, Frey Otto, and the equivalent architects who are working in that domain. So these tensile structures have load transferred via the membrane of or the body of the tensile fabric or tensile concrete or whatever tensile material. So the material is a membrane, can be considered to be a membrane, that's okay technically. So the load transfer in these tensile structures are by membrane action. Finally, let's say you wanna create a telephone pole, or it's called a gin pole, but let's say you're in the army, you're going to war, you want to set up a telecommunication pole very fast, you don't have time to dig up deep foundation, so you set up a pole, but then the wind is gonna make it fall over. So in that case you would tie these you would tie 4 ropes. So in that case you would tie 4 cables from the point on the pole, the upper some point near the top on the telecommunications pole, and stretch it out to 4 points in 4 corners, at least 4 points. So they are the vectors. So wind is flowing in this direction, the tension on the pole, the cables on the that side hold the telecommunication tower erect. Wind is flowing from that direction, the tension in these cables hold it erect. Look at the O2 Arena in London, you would find a similar kind of an arrangement that holds the dome together. So that's the vector action. Vector means a magnitude in a particular direction. So if you have cables that are by vector action keeping the pole erect, so that is what they mean by vector action here. It's a very easy question for those who have an understanding of structures or are working in the field of structures, or go to webinars, seminars, or discuss about structures in general. Otherwise, suddenly for a student of architecture this might be a very difficult question because of the twisted terminologies that they have used. But anyways, let's move on to the next question. I think I've sufficiently answered to your satisfaction the meaning of each of these terminologies. Okay, the next question is again pretty easy. They are just testing your concept of low safety, factor of safety and loads. So they have said there's a 20-story building, and there's a lift which is working inside that building. The lift by itself, the lift car by itself has a weight of 750 kilograms, and the maximum load that the steel rope by which the lift is hoisted, the maximum capacity for the steel rope is 39,000 kgs. But they have asked you to consider a factor of safety of 20. So for a factor of safety of 20, which means you have to take a load, a maximum load assumption that is 20 times 120, the maximum load assumption has to be 1/20th the ultimate strength of the steel cable, a factor of safety of 20. You don't multiply 39,000 by 20, you divide 39,000 by 20. So it should come to be around 40,000 by 20 is 20, so something slightly less than 2,000 kgs. So yes, so the load that you can assume for this sum after having divided the ultimate strength of the steel cable, which is at 39,000 kgs, by the factor of safety of 20, it turns out to be 1950 kilos. So you would consider, you would design the lift for X number of people such that X number of people add up to a total of 1950 kilos. Now this is a 20-story building, so they have taken a factor of safety. Not because it's a 20-story building have they taken a factor of safety of 20, no. They have just given the example case here. It can vary. I would say the 20-story is a decoy, or maybe just a extra information which is not relevant or required specifically for this kind of a sum. Next, after having calculated 1950 kilos, the lift itself is 750 kilos. So you subtract that from the total load, because the steel cable has to hoist both the elevator and the people inside that elevator. So you subtract 750 from 1950, that gives you 1200, and every person on the elevator is supposed to have an average design weight of 75 kilos. Obviously you would say, what if a child gets up on the elevator? That's not how technically things are calculated. You take an average weight, so it's 75 kgs on average for every person that might get up on the elevator. So 75 twos are 150, 115 eights are 120, so 8 twos are 16. So a total of 16 people can, I mean it's a lift designed for 16 people at the most. So whenever you go to some building, you get up into a lift, you would see a total capacity is mentioned. So this is similar to how the capacity is calculated. So let's move on to the next question. The reason for asking these types of questions is because they want to check if you are trying to, if you're looking for a career in architecture masters, whichever stream you go for, maybe especially like if you go for BM, the way I went for it, they would want you to have an understanding of what that maximum capacity means. What if one extra person gets on the elevator and they say nothing happened, and they say okay, it's a wrong information pasted on the elevator, it's only because a factor of safety has been calculated. Try putting in 100 people in the elevator, it's going to crash. Anyways, stories apart, let's move on to the next question. Now this question I'm not going to solve mentally the way I'm solving the other questions, because a lot of calculation is involved, but the concept behind these kind of questions are very simple. You have a it's a question on bending of an object or the bending theory. So they've said there's a beam which is bending, and they've given you a moment of inertia, they've given a moment or whatnot. What have they asked you to find? They've asked you to find the bending stress, which means they must have given you the moment of inertia, the bending moment, and the distance of the neutral axis from either of the top edge or the bottom edge. Anyways, for these kind of sums, the concept of bending theory, bending stresses, the neutral axis, and even limit state of collapse and how bending occurs, etc., have to be proper. Once that is done, you just use the formula of m by I equals to sigma by y equals to E by R. You just use the formula, put in the numbers, whichever is given. There are two equal to's in between. So obviously, I mean, out of 4, 1 would be unknown. Out of 6, 1 would be unknown, or 2 would be unknown. So you just use the formula and just get the answer. It's very simple, nothing much. This is an otherwise easy question, but you would have to know the reason why we went from working stress method to limit state method, and you have to know the entire concept behind the limit state method, and you would also have to know the graph of how the concrete and steel behave under the limit state method, why the factor of 0.002 comes in, which is the stress induced in the elastic region. So they have simply mentioned limit state of collapse in the question, so that's a hint. Use the formula or use the technique for limit state method, which is 0.87 characteristic strength of concrete by Young's modulus of characteristic strength of steel by Young's modulus of steel plus 0.002. See, I remember the formula. Simple. See, it's easy, but if you know the technique only then. So there was one with 1% steel, and there's this one with within the limit state of collapse. I would say these are the rare types that have been asked in the exam till date. Beyond that, they only focus on shear force and bending moments, but you can expect more such types. So be very thorough with IS 456, all the concepts in IS 456, because the exam is shifting its strategy from being a monotonous predictable one to unpredictable one, in which your acumen for your IQ, your acumen for depth of knowledge is tested very hard. They do not test your memorization skills. So you just put in the numbers in the formula, you get the answer for this. So there's no point explaining, because limit state method is itself a 1 hour discussion. But I just wanted to mention it in this video. Let's say you are revising for your exam, or you know, okay, this is something that I have to revise. Now put in half an hour and revise, that's all. But yes, this is a very unique sum, easy sum, but you should know the theory. Is there anything else that we have left? Let's see, maybe I'll take a question or two and then we'll put an end to this video. I think this is the last question I'm going to take for the numerical section on mechanics in this video. Otherwise we can keep going on for 6 hours. Generally that's how long mechanics sessions are. But they've given a diagram of a truss with a force acting at a diagonal on the point P, and they've asked you to find out the force in the member UR. So you should be thorough with the concept of a zero force member and the two laws that guide how zero force members can be calculated, or identified rather, not calculated, because the entire law for identification of the zero force member is based on the presumption that you don't have to calculate. You just look at it and you know it's a zero force member. So this, as we can see, is straight away a zero force member. You know the force would be, the countering force would be straight away collinear with the angle of the force acting on this truss. And the third one need not be at 90 degree, it can be at any angle if you go through the law properly. because UR is the third member which does not have any other force acting on itself, would be a zero force member in this case, because the force acting on the truss is getting countered by the member PS, which is also at the same collinear angle of 45 degrees. Very simple, just be thorough with the zero force member concept, and these kind of questions are all visual. But remember, if there are more than 3 members at a point, because zero force members are applicable for a point which has 2 members or maybe 3 members. If there are 4 members, you just can't look at it and say it's a zero force member. You have to use some other method. So be very careful. The laws are applicable for 2 and 3 members only at a point, not for 4, not for 5, not for 6. No. So be very careful with that. But generally those higher concepts are given to civil engineers in their exam, but even if they do, you would know. So with this, I think I should end the video for mechanics, and you can reach out to us for guidance on any of your career related queries or GATE exam, or even portfolios, resumes, internship, job related queries, anything, anytime you want help for your career, we are there for you. And I'll see you again at AvidForte in the few further videos that we'll publish on our channel. And you can always visit our website, our social media handles, and put in your comments, your queries. I would also be putting my contact details, my personal number on the description. You can give us a call anytime, 24 hours a day. We are available for helping students. If I can make that time, I'll definitely give you my time. So thank you guys. See you in the next video. Bye bye.